Okay, everyone, we're going to be looking at today the structure of the solar system and start on looking at the structure of the universe as well. So we want to know today how our universe is structured and how the planets came to be formed. So we want to look at what makes up our solar system, how are the inner and outer planets different, and why do scientists believe our planets are lined up like they are? So why do they believe that the inner planets are where they are and the outer planets are where they are and they are like they are? So some of you might have done a bit of this already earlier this year, and if you have done, then great, and the early parts of this should be really simple for you. But we're going to expand on this a little bit and start to look at, especially this last bit, looking at how the solar system was formed, how our sun and our solar system and our planets were formed. So first off, what I would like you to do is I'd like you to try and tell me what you think these things are. So what is the Earth, the Sun, the solar system, the galaxy, and the universe? What are these things? So I'd like to pause the video now and try and write your own definition. So for example, you might put, I think the Earth is, and then tell me what you think it is. And then I'll give you the correct answers afterwards and you can correct anything you need to. So if you pause now and have a go yourself. Okay, so we should be back now. So if you've not done that, just do that already. And these are what I would put as the answers, and you can correct yours as you need to. So the Earth is our planet, and it's the only one we know of so far which contains life. But we're going to have a look at that later in this week. Are we the only one that contains life? And what other planets might contain life? The Sun is our closest star, so the star which is closest to the Earth. It's just like any other star, though. All the other stars in the universe that you can see when you look up at the night sky are very much the same as the Sun. The solar system is the Sun and everything which orbits it. So everything within the Sun's gravitational pull that orbits the Sun, orbit, by the way, meaning goes around. Okay, so the word orbit means to go around. Okay. A galaxy is a collection of stars, so usually billions of stars, okay, in a galaxy. In our galaxy, it's called the Milky Way. And the universe is all of the matter in space considered as a whole. So if you look at everything, all the different galaxies, all the stars, all the planets, everything there is that we know of is the universe. Okay, moving on. So what I want you to do next little task, is I'd like you to try and draw, so try and do this in your book somewhere or on paper. I would like you to draw what you think the sizes of Earth, Jupiter and the Sun are to scale. So just for an example, if I drew the Sun, I might draw a little circle like this, and I might write in the middle of it, Sun. Okay, and then I might draw next to it however big I thought Jupiter was. So I might think Jupiter is that big, or that big, or that big. Okay, you draw however big you think Jupiter is compared to your first circle of the Sun. And then again for the Earth, how big do you think that is? Do you think it's this big, this big, this big? How big do you think the Earth is compared? And just label them. So just pause the video now and have a go by yourself, please. Okay, if you can, should have started again now, should have done that. And I'm going to show you again what the correct answer should be. So compared to the Sun, all of the planets are tiny, especially if you look at the smaller planets like the Earth. So this is a picture of Earth, the Sun, and Jupiter. So this little tiny dot here is the size of the Earth. Okay, if that makes you feel a little bit small. Because we're on this tiny, tiny little rock orbiting this big sun, and the Sun's not a particularly big star either. It's just a normal size star. And Jupiter, obviously a lot bigger than the Earth, and a lot smaller than the Sun. In fact, you could fit 109 Earths in a line across the Sun, and they would still just, they'd make a diameter of the Sun, so they go straight across. The diameter meaning the distance across there. The little dark spots, just in case you're wondering, they're just sunspots. They're just areas of the Sun which are slightly hotter or colder, so they show up a slightly different colour. So just to give you an idea of how big the sun is compared to Earth and Jupiter. And now normally when you see pictures, you don't see this. This is not shown. And the reason is that you wouldn't be able to draw it. So if you drew this in a textbook, then the sun would take up most of your page and the planets would be tiny. Okay. And again, with the distances as well, normally you'd see in a textbook, you see something like this with the sun, and then you'd have next to it, you'd have Mercury here. Okay. I'm not going to go into the rest of the planets, so I'm asking you to do that in a minute. And then you'd have the next planet over here somewhere, and then the next one. But they're actually really far apart. So planets are actually very far apart from each other compared to the size of the planet. So they should really be drawn further away. But we can't do that because of space that you have to draw a picture. So next thing I would like you to do is to name the planets in our solar system. This is something you should be able to do, I think, especially for a lot of you have done this earlier this year. And all of you will have done this in primary school, I am absolutely positive. So can you have a go now, see if you can write down the name of the planets in our solar system. Okay, so pause now, see if you can have a go. And if you're not sure, okay, so if you had a go and you're not quite sure if it's right or not, see if this helps you. So this is a mnemonic that helps to remember the order of the planets. Okay, so my very easy method just speeds up naming. So see if that helps you. Okay, pause it again if you need to. If you've already done it and you think you're confident, then just carry on. I'll go through them now. So we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. Now you might notice that Pluto is missing off there. I know most people now know that it's not considered to be a planet anymore, as it is not big enough and it does not take up. It's not the only thing which is out there. There's lots of other what we call dwarf planets out where where Pluto is as well. So we don't call Pluto a planet anymore. Right. So using these, I would like you to have a look at this diagram. So this is a more accurate diagram of the distances between the planets and the different planets. Okay, and I'm going to go through a few of these and then you're going to have a go at drawing this yourself and labeling a few things on here. So first off, we've got Mercury, Venus, Earth and Mars, and we call these for here, we call those our inner planets. Let's change the colour to make it stand out a bit. So we call those our inner planets, and they are the ones that are closest to the sun. They are small, they are mostly rocky, made of rock, and they are closer together. Now, when I say closer together, they are still very, very far apart. Okay, so they're not actually close together, but compare the distance between these to the distance between the like larger planets out here, and it's much bigger. Okay, so the closer together little rocky planets are called our inner planets, and then we have the ones further away, which we call collectively our outer planets, or we call them sometimes our gas giants. We're just going to call them outer planets for today. Okay, so these are our outer planets, and these are much larger. They are mostly made up of gas, or we sometimes call them gas giants. Now, the actual outer ones, so Neptune and Uranus, we sometimes call those ice giants because they're so cold that the gas freezes to ice. So they're sometimes called the ice giants rather than to separate them from Uranus and Saturn and Jupiter, sorry. And these are much further apart. So the distances are much bigger. So there are the differences between our inner planets and our outer planets. So the inner planets are much smaller and rocky, whereas the outer planets are larger and made of gas. And the inner planets are much closer together, whereas the outer planets are much further apart. I've got a couple of other things on here as well. So I'm just going to highlight these ones to make them stand out separately. So we've got our asteroid belt. Try a different color. Oh, so we've got our asteroid belt here. Well, that doesn't work very well, does it? Stick with that. And our Kuiper belt at the end, which is where Pluto is. And these are collections of debris that are left over. So small chunks of rock, and in the Kuiper belt particularly ice, which are kind of just orbiting around the sun, and they're leftover bits from the start of the universe, and they can tell us quite a lot about how the universe formed, because they're just leftovers which have been floating around ever since the start of the solar system. Okay, so from the formation of the solar system, when the sun came together and all the planets came together, these are the leftover bits that were left. Right, what I would like you to do with this now, so have a last look at this if you need to. I would like you to draw a diagram like the one above of the solar system and label the planets and other features. And I'd like you to describe underneath it the differences between the inner and outer planets. And can you try and do that in full sentences for me, please? And then if you get a chance, if you can have a go at this as well, it'd be excellent. Can you explain why you think the inner and outer planets are different? So why are the inner planets so close together, and why are they made of rock, and why are they small? And why are the outer planets far apart, made of gas, and really big? Okay, so have a go at that now, and pause the video and answer these questions, draw the diagram. Okay then, so we're now going to have a look at how the universe formed, or how we think it formed at least, based on mostly the evidence that we've got from our own solar system. And this is kind of the accepted theory today about how the solar system formed and how the sun and the planets all formed. So we predict that the early solar system was something called a nebula. Now, a nebula is a collection of gas in space, okay? So a collection of mostly gas and rocks in space. And they're just floating around freely like this, and there would be billions of miles between the individual gas particles and individual pockets of gas and dust that make up a nebula. So there are tiny little bits of this, and if we say that each one of these blue particles is a gas, mostly hydrogen, and each one of these little particles here, if we say that is a rock or dust particle. So it's mostly gas and dust, but almost all of it is a gas. Okay, so there's loads more gas particles than anything else. So what we predict happen is that in the early universe, there were forces of attraction between the particles, and forces of attraction which we called gravity. So, for example, if we had these two particles here, this dust particle and this gas particle, there would be forces of attraction pulling these towards each other, and that would cause them to move and to come together. Okay, so that would cause the particles to come together. Now, after they've done that, that would cause then an even bigger force of attraction between the particles around it, because they join together. So then all of the particles around this would start to be pulled together because of gravity. So gravity will pull every single particle around this into the same place. So what we would end up happening is all the particles around the middle would start to pull together, and you will get especially all the gas particles starting to form into a much dense, a more and more dense thing in the middle, which we call at the minute, we call this a protostar. So this is an early star where we're getting all the gas and a few bits of the dust, solid dust in there as well. Okay, and that is going to pull in most of the gas particles, almost all of the gas particles in the solar system, okay, or in the nebula around it. So this protostar, it will eventually pull in enough hydrogen that it will get hot, and eventually the hydrogen molecules will fuse together, so you get hydrogen plus hydrogen, and they will make helium. And you might remember this from paper 1, hopefully you do, that this process here is called nuclear fusion. So this process is called nuclear fusion. So when that happens, that causes this to not become a protostar anymore, but to become a star. Okay, and that is then able to start shining, it starts giving off light. So once that has happened, so we've got our star in the middle, but we've also still got these little bits floating around. So these will start to orbit our star because gravity will keep them in orbit around there. But if two bits are orbiting, eventually they will start to form together. Now, if you look in the middle bit, all of the gas has been pulled in. So only what is left is a few bits of dust and rocks which will form the inner planets. And what will happen outside of that is the few bits of dust will still be there, but the bits of gas that are orbiting will start to form together into the outer planets, and they will again all form together to form our gas giants. So this is why, or this is what people predict, is why we have our inner planets much closer to our star, where all the gas has been pulled in, and our outer planets in orbits around the star much further away. Because again, if you look at the distances we've got here, okay, we've got our inner planets not that far away, quite close, whereas our outer planets are much further away. So this would be our outer gas giants. So because there was more gas in the outer solar system, further away from the star that wasn't pulled in, that's why the gas giants are able to form further out into the solar system. So what I want you to do, if you need to watch back over this and try and do this as you're doing it, as you're watching it, right, feel free. But I want you to try and answer this question here. How did the solar system form? So I want you to say it started with a what? What do we call the thing at the start? I want you to say what force was involved in bringing the planets and the sun together? How did the Earth and form? How did this, and also how did all the planets form? So how did the gas giants like Jupiter and Saturn form, and how did the sun start to shine? You might want to do that bit up a bit earlier than that, I think, because I discussed it a bit earlier on in the kind of process of talking about this. So work your way through this, watch back through the video if you need to. So scroll back a little bit to watch again as you go through these. But work your way through and discuss how this happened, okay? And if you can you try and explain why the inner planets are rocky and the outer planets are formed from gas? But you should be able to do the extension in the answer, I think. Okay, so pause the video, work your way through that, answers in your books as one full answer, please. Okay, when we're ready, I've got one more thing to ask you before I finish the lesson on this, which is, in fact, before I go on that, we'll go through the answers for this. So you want to be saying that the new star system is called a nebula. It is brought together by gravity, and the Earth formed because gravity pulled all the dust and rocks together to form a planet. And you could say that Jupiter and the gas giants formed because there was gas in the outer solar system, which is able to pull together to form the gas giants. And the sun started to shine because gravity pulled enough of the gas in the nebula together, and there was enough heat and pressure for fusion, nuclear fusion, to start to happen, and this then emits energy in the form of light and heat and every other type of wavelength of electromagnetic radiation into the universe. Okay, last little bit I want to show you. So this is at the moment the most accepted theory, that it should end up with the inner planets being rocky because all the gas from the inner solar system gets pulled towards the sun, and then there be gas left in the outer reaches of the solar system to form the gas giants. And scientists believe that this would be true for almost all stars until one day we started discovering stars around other solar systems, okay, or other stars. And the first one we discovered in 1995 was got a really inventive name, okay, as most stars have, it's just a load of numbers and letters. But it's called Pegasi 51b. And it's the first exoplanet that was discovered, so the first planet discovered around another star. And it was nicknamed kind of a hot Jupiter. So this was a gas giant which orbits very close to its star, and it doesn't fit the theory that we're used to. Okay, so it doesn't fit with what we think. So currently we think that we should have gas giants further away, and we should have small rocky planets closer to the star. But this was a big gas giant, the size of Jupiter. In fact, I think it's a little bit bigger, and it was really close to its star. So what should scientists do with this new information is what I want to ask you. And I'm not going to tell you the answer in this video. I want you to write yourself an answer down and send it to me, and we'll discuss it when you get back, what you think. Okay, so what should scientists do? We found out that what we thought was correct for all stars, we predicted this would be correct for all stars, and then we discovered a planet around another star, and this was not correct. So what should scientists do with this new information? So write yourself an answer down, and we'll go through that when you come back. Okay, that's it for today then. So hopefully you've been able to get everything you need from this. Let me know if there's any issues. Get in contact with me and I will help you with anything you're stuck with.